Hello everyone, how are you? Welcome to a very exciting series of learning. From today, we are going to deploy our first cloud-based solution in an EC2. This is a Java-based application we will deploy in an EC2. So to build the application, we need network infrastructure. We will build everything from scratch. We use Terraform to build the whole network infrastructure like VPC, subnets, route table, internet gateway, NAT gateways, and so on. Then we will build the EC2 instance and deploy the instance to our network. Next, we will build the Spring Boot application and deploy that in an EC2 instance. So there will be three parts of the video. First, we will be building the network infrastructure. Then we will be building the EC2 instance. Then we will be deploying our application to the EC2 instance. This will be very interesting video if you want to deploy your first application to cloud. I hope you are interested and me too. Those of you who want to learn Terraform, kindly watch this video to grab knowledge about the networking part, architecture, how to build that. We can definitely do it with defined template, but you can create it of your own as per your need. So again, if you are new to this channel, kindly like, share, subscribe for more latest updates and comment your thoughts as well. And so sit tight and enjoy. So this is a short introduction of what we will do in this particular video. So what we will do, as I said, we will be deploying our first web application in cloud. So we cannot do that by default, right? So before that, we need some prerequisites. So what are the prerequisites? So the prerequisites is we need to have one network infrastructure where we will be deploying our EC2. So if you know how to spin up an EC2 instance, you probably remember that we need to select one VPC where we need to deploy our EC2 instance. So we can very well select the default VPC that AWS provides for our EC2 to deploy, but we will not do that. So we will create our own VPC, our own subnets and everything, route tables and everything, and we will deploy our EC2 instance on that network. So we will not use the default network provided by AWS. So this is also a kind of a learning. That's why I am making this video. So if we know that how to develop an infrastructure entirely, it would be also helpful for you as well in future. So we will develop the entire infrastructure that you see here in Terraform. What we will do, let's go one by one. First of all, we need one AWS account. Inside that, we will spin up one VPC. So this VPC have two subnets. One is public subnet, one is private subnet. In the public subnet, we will spin up our EC2 instance, but this public subnet cannot interact with internet directly. So the main difference between a public subnet and a private subnet is nothing but having this internet gateway attached to these subnets. So if we have a public subnet, inside that public subnet, we have a public route table. We will create one route table, and that route table will attach to the internet gateway. So we have our public subnet open to internet with this route table. So that means this is our public subnet. And in the private subnet, not to expose this over internet directly, we will spin up one NAT gateway in our public subnet. And we will spin up one private route table in the private subnet. Through that, each and every traffic from this private subnet will go to the NAT gateway, and the NAT gateway will contact with internet gateway directly with the elastic IP. So this is what the entire architecture. So if any user wants to interact with our private subnet, so it has to go through this internet gateway, then this route table, then this NAT gateway to our private route table, then this private subnet it will come. And if any if any user wants to interact with the public subnet resources, then it needs to go to this internet gateway, public route table, and then public subnet resources. So in this particular video, we'll make it very simple, and we will spin up the EC2 instance in this public subnet itself. In the next video that comes in the part 2. So this is not part 2, this is part 1. In part 1, we will only deploy the entire infrastructure as code in Terraform, the networking infrastructure. So in part 2, we will spin up one EC2 instance also in the public subnet, and in part 3 we will actually deploy our web application in that EC2 instance. So we will build up one Java based application, and we will see that if we invoke the EC2 instance public DNS, then the application will work. So but right now we will only code our infrastructure with Terraform, and we will deploy everything, and let's see how it works. So I have opened up one empty repository with the IDE. I am using PyCharm as an IDE. And also I have uploaded all the code to this repository. I will make it public, and I will give the link to the description box so that you can take the code as well from this repository. So I will refer to this code base here and build up our infrastructure. I have also opened up the AWS account where I will be deploying the network infrastructure overall. So let's go one by one. And also I have opened up the terminal. So if you see right now, there is nothing. So the terminal is pointing to this folder that I have opened up. Now let's see what we have done. So we have only opened up the AWS account, and this is fine. Now we need one VPC. So to have VPC, what we need, so first of all, we need one backend. So what I am going to do, I will create one backend.tf file. So why this is needed, and I also need one provider. So everything, as I said, uh, we will do from the scratch. So I think this is wrong actually. So I don't need Python, I need Terraform. So okay, so I need the backend. So why we need backend, please refer to the earlier video of mine from Terraform state file. So we will save our state file remotely to the bucket, and also log our state file with dynamodb. This is why we need the backend, and we will refer to the dynamodb and s3 there. So please refer to that video. You will get to know like what is state file and how to lock it and everything. And also we need provider. So if you also don't know provider, so please refer to the other video as well, where I have explained how to enable Terraform or how to work with Terraform. So you will get an idea. So first of all, let's give some code in the provider section. Now I have written some code here. What it says is that my provider is AWS, and the region is the default region. I have to give one region here, so I will declare the region right now. And then Terraform, the required providers is AWS, and the version is greater than 4, and the source is HashiCorp AWS. So this is my provider and its version. And also I have defined the backend. So I will use backend for S3, and the bucket name is this one. This I have to create, and I will create now. The region is this, and the key where in which folder. This is the folder that I want to save my state file, and my state file name is terraform.tf. And the dynamodb for locking the state file is used here in this name. So what we have to do? First of all, we have to create one vars.tf file to declare the variable. So let's create something here, vars.tf, and inside this vars.tf I have to declare variable. And what variable I need? First of all, we go to the provider and select this variable. So this is the variable, and the type is string, and there will be one default value. I will use US East 1. So that's it. So I am saying that AWS region is the default region, and default region is US East 1. So now the error is gone. So if you are using HashiCorp Terraform language less than 12 or 13, so you have to give this var.aws region kind of like this. You have to give it from reference, and then you have to refer the variable there. But as I am using recent version of Terraform, so that's why I don't need to give that. Also I need to so backend is also there, then provider is also there, my vars is declared. Now what we have to do, if I if I go to backend, so this is the backend where my state file will be stored. So first of all, I will create a bucket. So let's copy this bucket name and go to my management console, and this is 3, create bucket. Let's give a bucket name like this, Terraform state information, and I will not select anything else, and I will create the bucket. Apart from that, we need to create one dynamodb table, and I will go to dynamodb table, I will create a table, and I will give the table name as this one. This is my table name. And also I need to give the partition key here. So for partition key, I will mention it as a lock ID. So this is my DynamoDB table, which will hold the lock state file locking information. So I will create the table. So this is the prerequisites. You can do it. You either do it or you don't do it. If you don't do it, then you don't need to define the DynamoDB table here. You just need to define the bucket name and the key. That's it. So the state file will be saved in the bucket, but the locking will not happen. Even if you don't want to, use this bucket as a Terraform state file in backend, you just don't have to define the backend S3. So the state file will be stored in your local itself. Fine. So my provider is ready. My provider is ready. My backend is ready. Now what? So then now what we can do, we can initialize the Terraform. So as my provider is already there, so I told Terraform that this is my provider, this is my AWS provider, this is the version of the provider and everything I have given, and also I have selected the backend as well as S3 and DynamoDB locking. So what we can do, we can try to initialize our project. So let's do Terraform init. So if you don't know Terraform init or what it works, please refer to the earlier video of Terraform. You will get to know that what is why we are doing this Terraform init. So to be a very layman perspective, so Terraform init actually initialize your project into your local, and it also initializes everything to initialize the backend, initialize the provider and everything. Okay, so before doing this init, what we need to do, we need to configure this AWS credential where we will be deploying our things, where we will be deploying our infrastructure. So to configure this, we need to give AWS configure, then the access key. This is my access key, and it will ask for secret key, and this is my secret access key, and region name is fine, and everything is fine. So my AWS configuration is done. So I will clear the screen, and I will now do a Terraform init. So let's see. So we see that the Terraform initialization has been done. So it has initialized the backend, it has initialized the provider plugins like the HashiCorp AWS version. It took 4640, which is the latest one, and it also created .terraform log file. We can see the log file here. We can see the log file here, and here we will be able to see the providers. This is the provider version it has downloaded, and the log tf state file also it has generated here. Now, what we have to do, so my Terraform initialization is done. Now what we have to do, we have to define some VPC infrastructure, right? So let's go ahead and create the module of VPC. So to create the module, I will create one module here like Terraform AWS VPC. So this is my VPC module, and inside this VPC, I will create one file called vpc.tf, this file, and I need another file for my variable. So vars.tf. So this is individual. So this vars.tf is individually only for VPC. This vars.tf is only is for global. So okay, now my vpc.tf is here. So what we are going to do, we are going to write some code here for our VPC to spin up. Now this is the code that I have written, and let's go one by one what it does. So I will create one resource. The resource is AWS VPC, and the AWS VPC and the name of the resource is or my VPC name is production VPC, and this is a CIDR block. So CIDR block I have not given right now. I will take it from variable as I have not declared any variable till now. So this is why it is kind of showing as red. That's fine. Now the enable in a DNS hostname, this one I have given as true. So if I enable the DNS hostname, then if I spin up one EC2 instance in the VPC, the hostname will already be enabled. So we don't have to only select the EC2 IP address and check that in the browser for the reachability. So this is fine, and my tags. This is the tags that I have defined the production VPC. This the name is the key is the name and the value is production VPC. Now my VPC, if I see the architecture diagram, so this is how we create a VPC in Terraform. So this block will create a VPC inside the Terraform. Now we only don't need that VPC. We need one subnet, public subnet and private subnet as well. So what we have to do, this one. So we are creating another resource called AWS subnet, and this subnet type is public subnet. So if you see this two resource, right? This is public subnet resource and this is the private subnet resource. Everything is same. So CIDR block, I am giving that CIDR range. This I will pass in from the variable. So till now the rate is okay. VPC ID, I have to refer to the VPC ID that I have created, and I have to refer to the ID. So how to refer that? To refer that, we need to select this VPC ID equals to AWS VPC. So the type is VPC, and what is the logical name is the production VPC. This one, production VPC, and this is the ID. And the ID, it will take the ID and it will refer to the public subnet to this VPC. Now, fine. And availability zone, this is the availability zone that I am selecting, and the availability zone is US East 1. So on US East 1, I will be spinning up one public subnet for this VPC. This is what I am telling Terraform, and the name of my public subnet is public subnet 1. And then another resource. I am creating another resource as AWS subnet. More or less everything is same, only the name is different, private subnet, and the CIDR block is private subnet CIDR. This also I will pass in from variable, and the VPC ID is the same VPC ID that we have referred here, the one that we are creating, and the availability zone is the same. So in one availability zone, I am creating two subnets. One is public and one is private, and the name here is private subnet. So this is my private subnet, this is my public subnet. So if I see the architecture diagram now, my VPC is ready, my public and my private subnets are done. Now what? Next, we are creating route table. So two route table I am creating. One is public route table, another one is private route table. So if we see the architecture diagram, so public route table I will be referring in public subnet, and private route table I will be referring in private subnet. So how to create the route table? So to create the route table, we have a property AWS route table. So this property actually creates the route table, and my route table name is public route table, and then the VPC ID. So the route table needs to attach the VPC ID to it. So the VPC ID is the same one that we have created. AWS VPC type is AWS VPC, logical ID, and then the ID, and then tag. My public route table name is public route table, and another one I'm creating is private route table. So resource AWS route table, same. The name is private route table, and the VPC ID is the same VPC ID, and tags is same. Till now, if you see, I don't have any difference between the public subnet, private subnet, or the public route table or private route table. So this public route table and private route table kind of same way it has been generated. So how can we differentiate, or how can we say that this route table is private and this route table is public? Because there is no other thing that we have given. We have only attached the VPC ID to it, and that's it, and we have given the name as public. So by giving the name as public route table, it does not makes it public, right? So we have to define something so that it makes this route table as public. So what is it? So if you scroll down here, you see that route table association. So this route table association here makes this route table associated to the public subnet, this one. So this one, what it's saying, that it has an association to the resource type is AWS route table association, and the logical ID is subnet association. And what it does, this route table association takes two parameters. One is route table ID. This is my public route table ID. This one we are creating here, and the subnet ID. And the subnet ID is the public subnet that we have created here. So I am attaching with this route table association the public route table with the public subnet, and I am attaching another one. I am creating another route table association, naming it private subnet association, and I am attaching the private route table, naming route table, and the private subnet to it. So here, if you see the architecture diagram, I have attached public route table to public subnet, private route table to private subnet. Till now we don't know either this is public or this is private, or this is public or this private, because attaching the public subnet to public route table and naming just public does not make the whole infrastructure as public or private. What makes is the next part. So if you see the next part, I am creating an elastic IP. So this elastic IP, we will associate the elastic IP here with NAT gateway. So to create an elastic IP, I am saying AWS elastic IP. This is the property by which we have to create elastic IP, and this is the logical ID. And we need to attach this elastic IP inside a VPC. This is why I have given VPC as true. And this property is optional. You can either give this or you do not give this. Doesn't matter. Associate with private IP address. I am associating this one with private IP address. That's why I have given it. And the tags, the elastic IP tag is name and the production elastic IP. So I am creating one elastic IP. Now, what is the use of this elastic IP? So if you see here, I am creating one NAT gateway. So what is a NAT gateway? So NAT gateway is something by which private resources access internet privately. So my private subnet resources, if they need to access the internet, they cannot go directly to this internet gateway. They need something in between. So this is why the NAT gateway comes into picture. So I am creating one NAT gateway. The logical ID is NAT gateway, and the allocation ID is here. AWS, the allocation ID is the one where we have to attach the elastic IP. So I'm saying that the allocation ID is the elastic IP ID. So the AWS elastic IP for NAT gateway, this one, and the ID. And subnet, very important. So the NAT gateway, we have to place it in the public subnet. So this is the public subnet association happened here. So subnet ID, I have given AWS subnet, public subnet ID. And the tags, I am giving name, production NAT gateway. And this one is very important. I am selecting as depends on AWS elastic IP for NAT gateway for this one. So depends on actually holds these resources till this one is created. So the first this resource will be created, then the NAT gateway will be created. That makes sense, right? So if NAT gateway created first and it does not find the elastic IP, it will be an error. So this is why I have given depends on this elastic IP. So elastic IP will be created first, then it will be associated with the NAT gateway. So right now it's okay. So we have now a public IP with the NAT gateway associated. So still now makes sense. Okay, now we are going something there. Still, we don't have a public route or private route. Now if you see here, AWS route, I am creating another route. We have created this route, right? I am creating another route for my NAT gateway route. So what will happen to the NAT gateway route? So how NAT gateway will interact with internet? So NAT gateway will interact with internet via this route table. This private route table will come to this NAT gateway, and NAT gateway ID is the one, this NAT gateway ID. So the route is, a NAT gateway route is something that we have to associate this private route table and the NAT gateway. So this is the NAT gateway that we are creating here above, and the private route table that we are creating above. And the private route table, if you remember, the private route table is associated with private subnet. And I am associating this private route table now to this NAT gateway. This is what I am doing. So private route table, now my private route table is associated with NAT gateway. So till here my connection is coming. So my connection comes here. So my resources from private subnet through private route table comes to NAT gateway. But still it cannot reach internet. So how to solve that? To solve that, I am creating one internet gateway. So we need to create one internet gateway. So internet gateway is the one where the interaction will happen with internet. So internet gateway, and the logical ID is production internet gateway. I am associating one VPC ID. So I am selecting that inside this VPC only the NAT gateway will be created. Internet gateway will be created. and the name of the internet gateway is production internet gateway. That's it. But still I cannot reach internet. Why? Now the main part, I have to associate my public subnet or the public route table to my internet gateway. Then only I can reach to internet. This is what I have done here. So I have created another route for my public route. So my public route, anything with the public route that comes from the public subnet will come to this route table, and this route table is associated with the gateway ID, and I am selecting the destination CIDR range is like this one. So this two is very important, this part and this part. So these two part is very important actually. So this two part actually makes the whole infrastructure or the differentiation between the infrastructure as public and private. So I hope it is clear how it is defined. So first of all, we have created one VPC, then two subnet. This is the public subnet, this is the private subnet, and then two route table. One is public route table, one is private route table. Then association of the route table, public route table associated with public subnet, private route table associated with private subnet. Then we are creating one elastic IP for our NAT gateway. So the NAT gateway is associated with the elastic IP. Then we are creating one route for the NAT gateway route. We are selecting the private route table with our NAT gateway, and for public route table we have created one internet gateway and selected or provisioned the internet gateway with our public route table. That's it. So this is the VPC, entire VPC infrastructure that we have created with Terraform. So very simple, right? Now let's see. What are the error. So my error is that we have to define the variable VPC CIDR. So let's define the variable. So I have selected the variable here. So the my first variable is VPC CIDRs. Now if I go to VPC, we see that VPC CIDR, and the second variable is public subnet CIDR. This is the one, public subnet CIDR, and the third variable is private subnet CIDR, and this is the one, private subnet. So now there is no error. This is fine. So my VPC module is ready to launch. What next we have to do? We have to create the main method, main file. So I will create the main.tf where we will be calling the module, and I will paste some code here, and this is my code. Now I am saying that please, this is my VPC module, and refer to that Terraform AWS VPC, this one, and my and whenever we will pass in some variable. So if there are any variable here in this vars.tf, if there are any variables, we have to pass that from our main.tf. So right now we see that everything is error because in the main.tf itself, there we need to provision something, we need to declare some variable. So to do that, we can go to new file, then vars.tf. Okay, sorry, I think I already have a vars.tf. Yeah, okay, sorry. So vars.tf, and inside that we need to create the variables. And this is my variable. So my variable is VPC CIDR, public subnet CIDR, and private subnet CIDR. Now everything will be gone. So now there is no error. So my total network infrastructure is ready. So my module is VPC, and it will take the module from this source like this, and it will take this VPC.tf from here. And inside this VPC.tf, I have resources for creation, I have variable as declared. Now if I do this Terraform plan and everything, Terraform apply, it will be applied, but it will ask for this CIDR range. So I don't want to do that. So I want to pass this CIDR range with a variable file. So for that, I will create Terraform variables, tf-vars. So in this I will pass in the variable. So my variable is VPC CIDR. So my VPC CIDR range is this one, my public subnet CIDR range is this, and my private subnet CIDR range is this. I have made it 24 less because we don't need a whole 16 CIDR range. That's fine. So my entire infrastructure now is ready. Now let's do one thing. Let's revise this what we have done. So we have created one VPC module VPC. We see that with this, so the code will first come here from main, and from main it will refer to this VPC.tf. Inside the VPC.tf we have created public subnet, private subnet, route table, NAT gateway, internet gateway, everything. So whatever infrastructure you need for a project to run, everything I have created. Now quickly let's go here in our terminal. First of all, what we have to do, we have to again initialize. Why? Because we have created one module. So as one new module has been created, so we need to initialize again. So I will do Terraform init, and it will initialize the module. You see here, you will be able to see one module name. See this one is the new module name, and it has been initialized. Now everything is fine. Now I will clear the screen, and for checking purpose I will format the code a bit. So now everything is formatted. I will again clear. Now I will make Terraform plan. So if I do Terraform plan, it will automatically validate. So let's do Terraform plan and let's see if there are any error. Okay, I see now it has generated the plan. So let's see what are the plans there. So I see that in the Terraform plan, first of all, the creation plan is there. There is no update, no delete, nothing. So it has acquired the state log. That means my dynamodb also is working. And the module, first of all, it is taking from this module the elastic IP. So it will create the elastic IP. Then it will create the internet gateway. Then the NAT gateway. Then it will create the route, the AWS route again, the route tables. This is the public route table. This is the route table association with the public private subnet. This is the public subnet route table association. This is the subnet itself, private subnet, and this is the public subnet. And this is my main VPC, and this is the VPC, and I see the CIDR range. It has been taken from my TF verse variable. So everything looks fine. Now I will again clear the screen and do Terraform apply. Let's see. So it again says that acquiring state log. So it says that I will do as per plan creation of this 12 resources. Plan to add 12 resources. Do you want to perform that? If I say yes, let's see. If I say yes, what will happen? Let's go to first DynamoDB, and let's go inside this DynamoDB table, explore table item, and then run. Now I see that one lock ID has been created, and in the information I see that my name is there. So I have acquired the lock. So the lock has been acquired by me, and no one else can deploy resources. And if I go to S3, I open the bucket, I refresh this one, there is still no state file generated. Let's see. Okay, now I see that the application is complete. 12 resource added. Let's go to our AWS console and validate. And before that, let's see if any state file is generated. Awesome. So I see that one folder is there and my TF state file is generated. And is it there as well? Let's see. This state file, this is my local state file. So this is my local state file and this is my remote state file. Nice. Now let's go to our management console and validate if everything is working as expected. So let's go to first of all VPC. And your VPC. And I see that my production VPC, this one is created. This is my production VPC. The CIDR range is this one that I have given, and the tags is name production VPC. Fine. Now my production VPC and also this one DNS resolution is enabled. This is what we have given as only one property or host name. This one. Now go to subnets. And inside this subnet, I can see one private subnet and one public subnet is created. So the private subnet, the tag is the name is private subnet, this one is there, and the public subnet, the tag is public subnet. Now fine, and let's go to route table. So the route table, two route table is created, one for public subnet. If I go to the public route table and the details is this subnet association, we will be able to see the subnet association here. So we have explicitly given the subnet association. So my public route table subnet association is public subnet. So this is fine. This is what we want. And my private route table subnet association is private subnet. This is what we want. So this is my private route table. If we see the name is private route table, and subnet association is the one where I have associated private subnet. Everything is working as expected. Now my internet gateway. So I have created one production internet gateway, this one, and this is my tag. Name is production internet gateway. And egress only, this one we have not created, and the last one we have created is the elastic IP. This is the production elastic IP that we have created. And where is that? Tags, yes, the name is that production elastic IP. And allocation ID also, it has given one allocation ID is EIP. Fine. And let's go to the NAT gateways now. And inside the NAT gateway, we will be able to see that our NAT gateway is created. If I see the tag, this is what the NAT gateway is created here. And we see that this NAT gateway has a public IPv4 address associated. So let's see our elastic IP once more. And we see that elastic IP is 3212.241.109. This is the same one, 3212.241.109. So my NAT gateway has been attached to the elastic IP that we have created, and the subnet, it is under the public subnet. So as per this infrastructure, my whole infrastructure is ready now. My VPC is there, public subnet, private subnet. We have seen private route table, NAT gateway, internet gateway, public route table, and its association with public subnet. Everything is we have created. So my entire AWS networking infrastructure has been created now with Terraform. So this is what I wanted to show here, or in this first part, that how to create the networking infrastructure for our deployment. In the second part, we will be deploying one EC2 instance in this public subnet, and also we will do that with Terraform that I will show you. In this part, I will not destroy the resources because this is what I wanted to do, or I can show you how to destroy this one. So if you give Terraform destroy, and if you enter, it will destroy the whole infrastructure. So what I can do is I can show you anyway. So first of all, I will clear the screen, then I will do Terraform destroy. So this will destroy the whole infrastructure of ours that we have created. So this command will ask me for permission. So it is refreshing state for all VPC, internet gateway, public route table, subnets and everything, and it says that plan is that 12 to destroy. So do you want to do that? So I will give it as yes. So I will anyway create again. So my whole infrastructure is now being destructed, or destruction is there. So it will take some time. So this is what I wanted to show in this video, that how to create and whole networking infrastructure with Terraform. So I hope you enjoyed this video. Please watch out or wait for my second part, where we will be deploying an EC2 instance in our infrastructure, and then on the third part, we will deploy our Java-based application to the EC2 instance and access that from internet, and so that how can you deploy your first application into cloud. This is what. Thank you for watching this video. I hope you enjoy it. Please again. If you are new to this channel, kindly like, share, subscribe. Please give your comment in the comment section. Please give your comment on and your thoughts, that how do you think you like this video, what can be improved, or what do you want to know more. I will be back with the second part of the series, where the EC2 instance we will be deploying. Till then, take care. Goodbye.